questions just so that we keep this session interactive. So please type on your answers or any feedbacks in the chat window, and we would be taking up all the questions at the end of the session. So there would be some session, so intermittently just don't break the thing. You just type in the chat window whatever questions you have, and after the session is complete, we will go through all those questions and review it.
I request all the participants to mute your mic, and if you have any kind of query or any question, you can write in the chat box. We have question answer session at the end of the session. I will also provide one feedback link in which you have to submit your feedback, and once you submit your feedback with correct and registered email ID, you will get the e-certificate in your email address. So it will be at the end of the session, means after question answer session I will provide that link. So in between, if you have any kind of doubt, just write the questions in the chat box, and uh, at the end we have some question answer discussion session. You can unmute yourself at the end to interact with the speaker. You can also write in the chat box whatever the doubt you have. Okay, now mic over to you, Ronak. You start the session.
Okay. So getting started with 3D printing. So I hope like this 3D printing or additive manufacturing, these words have been heard by you at some or the other place. So in the today's session, what I'm focusing is briefing you very quickly about what is 3D printing, and my focus would be how you can play with the 3D printers, how you can start your working with the 3D printers and build your own products with it. So this would be more like a practical session instead of going for a theoretical based things. So let's start. So agenda for the today's presentation is I'll be briefing you what is 3D printing, then different types of 3D printing methods that are available, the most commonly available methods, then what is a workflow or how you start with the 3D printing. So what are the process you need to consider, what are the techniques that are to be followed. Then we will, after workflow, we will focus on comparing what is the difference between 3D printing and the traditional manufacturing process. Once we cover up the basic part, we will jump into understanding what is an FDM 3D printer, how does it look like, what are its basic components, and how to operate that. And then we will see what are the applications of 3D printing and what are the challenges that whenever person is working with a 3D printer, are the common challenges that he has to troubleshoot while working with it. Okay, so let's start with what's 3D printing. So 3D printing is a manufacturing process where you create the physical 3D objects using a digital file. This digital file is generally a CAD model, and the printing is done in a layer by layer method. Here, the entire 3D object is cut into three thin slices across the cross section, and each layers are then printed and stacked together. So what happens is, if you have a cube, that cube is cut into small or the thin slices, and then each slice represents the cross sectional area, and the printing is done across that. And layer by layer you keep on adding material and you create the entire product. This was the initial technology was invented by Chuck in 1984, and he invented stereolithography process. Then in 2005, so some advancements happened, and in 2005 this technology was made an open source. So now any manufacturer can create 3D printers. They can sell those 3D printers without paying royalty to anyone. And in 2011 onwards, this technology was well accepted by the industries, and the thing started like the uh, products developed or manufactured using 3D printers were started accept being commercially sold or manufactured by various industries, for which one of the pioneer in the aerospace industry. They created the first 3D printed robotic aircraft, and in the same year, a 3D printed car was made available commercially. So the entire body of that car and some of the internal parts were 3D printed. And since then, so after 2011 onwards, this technology has advanced a lot. And now this has been so widely accepted and used that in almost you name any industry, and this technology is used for manufacturing products for those industries. So now let's start understanding what are the different methods of 3D printing. So first, laser selective laser sintering, or well known as SLS. So in SLS, what happens is you have a laser, you pass the laser over a powdered material, and using the laser's energy, this powder material is fused and and a solidified object is built. This fused powder, this laser moves across the layers that I said. So wherever a layer is cut, and across that layer, whatever part or the cross section that is generated over that cross sectional area, this laser moves and it starts binding the material. And then once the job for one particular layer is complete, a new layer is deposited, and then the same process is repeated. So now for SLS, main advantages is like you can create parts which doesn't for which you do not need to add a support material, or you do not have to create support, because powder is already present for supporting any cantilever or hanging areas in your design. Then selective laser sintering supports metallic as well as nylon, and because of this, uh, the parts that are created uh, can be used in actual industrial applications. Then, uh, because of laser, the energy focus is at a very small, so the at a very small area, because of which uh, you can uh, create very fine, or you can have very high accuracy in your 3D printed model, and as well as you can manufacture very fine designs on it. This is very fast process because of laser. And the disadvantage of this particular method, like the primary disadvantage of using this method is like, because of use of powdered material, it requires a very clean environment, and during the operation it creates lot of environmental issues for the workers and as well as the surrounding, because the powder gets combined with the atmosphere. And another disadvantage is like, if you want to uh, create large objects, ideally the practice is when you have very big objects to be printed or the products to be printed, the layer thickness is kept generally higher, and for larger thickness, this particular method does not work properly. Now, second is fused deposition modeling, or FDM. So in FDM, the material is in a wire form and it is passed through a heated nozzle. When the material is passing through the heated nozzle, it its state changes from solid state to glass transition state. In that state, this material is laid over the cross sectional area for each layer, and then layer by layer the printing happens. And during this process, to cool or to bring the material from the glass transition state to solid state, the cooling is provided artificially or naturally. So artificial cooling, the cooling fans are available on the 3D printers. The major advantage of this FDM process is that it is the least expensive method, and it supports wide range of materials which starts from plastics, metals, woods, and even some of the polymers and carbon fibers. So even you can use composite materials for printing. The disadvantage of using FDM is that the parts built with this technique are a bit weaker in the direction, in the build direction. So along the z-axis, the uh, parts are weaker. So if you put the part in the tension along the z-axis, then the parts are going to fail at a lower stress values. Then during FDM, the temperature fluctuations happen because during the printing at some areas, the material has cooled down. At certain region, the printing is is happening, and because of this temperature fluctuations, the delamination happens, and sometimes the residual stresses or the bonding between the layers is not as strong as it should be. So these are some of the limitations. And for printing, the limitation is on the wire. So the thickness of the wire and the thickness of uh, the wire that is the nozzle is supporting. So all this controls the accuracy and precision of 3D printed part from FDM method. Now the third technique, and which is the oldest one, is stereolithography. So it is similar to laser sintering or SLS. Only thing is, instead of using a powdered material, here you are using a liquid resin. And the property of this liquid resin is that it gets cured and solidifies under the action of laser or UV light. And here also this laser or UV light keeps on coming up, like it moves along the cross section area layer by layer, and it solidifies the resin. The major advantage of this particular method is that it can create the finest and the most fine and highly accurate parts out of it. But the problem with this particular method is, because resin is used, which is a polymer, this the parts built with this particular methods, they decompose with exposure to sunlight and other environmental factors. So these polymers, they start breaking up, or the chemical properties start deteriorating over the period. So that is one of the major disadvantage of it. And second issue is that this is the slowest method among the three, because once the laser is there, it requires some time for curing and solidifications. If so because of that, this method is the slowest among all three. So now it's time for a short quiz. I'll be showing you three videos representing different 3D printing methods. In the chat window, you type uh, for which question, which 3D printing method we are showing. So has anyone? Yeah, I have got one answer from Ahmad Ali SLA. That is absolutely correct. So here you can see this is the resin bath, and inside the resin bath, you can see how this laser is moving across the cross section, and along the z-axis, the part is being pulled. So every layer by layer, this part is being pulled, and the printing is happening, and you create the entire model. Now the second question. Yes, uh, Ahmed, Akash, Mayank, Avi, Raju, Anali, Raj. Yes, all your answers are correct. It's FDM. So here you see how layer by layer the material is getting printed, and how the extruder or the nozzle is moving in the X direction, and how the printing is happening. And the last one, yeah, you can see. So see, every after the laser, the powder is coming up. Cool. So now let's understand what is a workflow. So in the workflow, the first step is that you need to create a 3D model. So for engineering applications, we create CAD models in any of the CAD modeling tool that you prefer, and the CAD modeling, the CAD model that you create needs to be exported in a neutral format, which is STL. This STL format captures the entire 3D model, so you can export the entire assembly or individual parts, and this is exported as an STL, which is a common neutral format across all CAD models. And the entire model is divided into small tessellated triangular objects, and this particular geometry is then imported inside a slicer, which is nothing but where this entire geometry is cut into layers. Then you arrange the like you lay up this object on the print bed. You set the printing properties, like at what temperature you want the nozzle to be, at what speed you want, what is the layer thickness, what how much, at what speed you need to build, if you need any supports, then how your support should be, what is the density of support, if you want that your part is very small and it is going to be difficult for it to uh, stick to the bed, then what kind of adhesion mechanism that you want to provide. So all this fine tuning and everything you need to do is in a slicer, and the output of this slicer is nothing but the tool path that is generated. And generally this tool path is nothing but the G codes. You take this G code and feed it inside a 3D printer, and rest of all the work is done by the 3D printer, and it starts printing the job. So now, because of this 3D printing, there are a lot of advancements happening in the CAD modeling part. So different techniques of how the CAD modeling is. One is the manual that we always do, or anyone does, is like you create the CAD model from the sketch, taking references from the images and drawings. But the new format, that is like 3D scanning. So this here you use your existing or the physical object, and you create the data point. So you scan the object, and the output of that scanning is nothing but a point cloud data. So entire object is represented as a point cloud data in the 3 dimension. And this point cloud data, when we import in a CAD software, we get a feature to convert it into a faceted model. This faceted model is nothing but the point cloud. The points are connected via triangular mesh, and this meshed or the faceted model is then converted into a solid, which we export it as an STL for the slicers. The major benefit of using this 3D scanning is done in creating replicas, uh, or if you have certain part for which you don't have the modeling details, you don't have the geometry details, and you need to build up. you need to create the digital copy of it. And one of the recent advancements that happened is in the photogrammetry. The photogrammetry, instead of it is also like scanning of objects, but instead of generating point cloud data, it generates, it creates the images, and like thousands of images are captured, and these images are then used to compute the depth, the topology of the object, and using this information you generate the faceted or the meshed object in the tool, and from there you create a solid object, and that solid object is being used for the 3D printing part. So the major use of this photogrammetry in the 3D printing domain is when you have large architectural or topological data which you need to for which this is used. So if you have a statue, you click thousands of pictures along all the directions, and then using the tool which supports the photogrammetry, you upload all those pictures to it. It will compute the three-dimensional details from those image and create a meshed digital uh, model for you. The another beautiful application of this photogrammetry is in the crash analysis. So so this automobiles do a crash analysis. So after the vehicle, when they do a crash test, in that time they capture thousands of images, and then using those images they compute at what was the impact on the car and what all damages are happening and other details. Now, let's understand what is the difference between 3D printing and traditional manufacturing. So, 3D printing initially started with the concept of providing a quick solution for developing prototypes or samples. And this is still this is still the main selling point for the 3D printing. But this is n- but the traditional manufacturing always focused on providing supporting large scale production. In 3D printing, user does not have to invest in additional tooling or assembly lines, whereas in traditional manufacturing, you need to invest in additional tooling or assembly lines. You need to create customized jigs, fixtures, and everything. But in 3D printing, you don't need all those things. Then in 3D printing, there is no restrictions in the design, and this concept came from the optimization, the design optimization that is happening. Because of this design optimization, the designs are coming up in a very innovative and creative way, and where it provides internal cavities and lot of complexities in the designs. Even inorganic designs are there, which is not possible to manufacture those kind of products with the traditional manufacturing. In aerospace, many of the brackets that are used to support the internals or the loads over the airplane, those are designed using the design optimization, and then those parts are manufactured using 3D printing. In 3D printing, it is an material addition process is happening, and because of that the waste is minimal, or it is most of the times zero waste. So you do not waste any material that is used for manufacturing, whereas in traditional manufacturing, it is most of the time it is a material removal process, and because of this lot of waste is getting generated, and you need to have uh, a raw material which is of a larger size to create the actual material that you want. So there is a lot of wastage happening there. The disadvantage in the 3D printing side was that the mechanical strength required is comparatively less than the objects created using the traditional manufacturing. And the reason for that is because of layer by layer printing, the grain orientation is not as uniform. Whereas in the traditional manufacturing, you take a piece of block, you cut the things, and because of that, the grains are always uniformly distributed and aligned properly. And because of this, the mechanical strength is higher in the traditional manufacturing. Now, what are the different materials that are supported across different 3D printing process? So the commonly used material, or the most favorite material, are ABS, PLA, HIPS, nylon, PET, wood, metals. So this ABS is very light material, and it provides a little bit of flexibility. So the parts printed are lighter, and they are little bit flexible in nature. And this material is used for FDM process, and during that, pulling the material from the spool to the nozzle, the force required is minimal. And the glass transition temperature for ABS is around 220 to in the range of 220 to 250 degrees. And the major disadvantage, so this is one of the most favorite material for all the industries, like for developing prototypes or the hobbyist 3D printing jobs that are happening because of all these reasons. But the disadvantage of using this ABS is it is not eco-friendly. And secondly, during the printing process at this glass transition temperature, it generates lot of fumes, and these fumes are dangerous for humans. Second one is PLA. That is one of the most cheapest and easily available material. This is a kind of thermoplastic. It is a thermoplastic, and it requires lowered glass transition temperature. So it is in the range of 180 to 200 to 10 sometimes. And PLAs are also lightweight material, but the main benefit of using PLA is that they are biodegradable and they are eco-friendly. So if your printing is not correct, or some issues happen, and your product is damaged, you can just crush those things and dump it inside the soil, and it's going to decompose. So there is no negative impact on the environment. And also, this PLAs are recyclable. So if you collect lot of waste PLAs with you, you can crush those things and again create a new PLA for you. The major disadvantage of using this PLA is when it is exposed to the environment, it absorbs moisture, and because of this moisture, the printed part loses its mechanical properties, and there are issues with the printing where the layer to layer adhesion is not very good. Another in if the purpose is for the flexibility, then nylon is one of the favorite material. It is strong, transparent, flexible, but it is very expensive. The filaments or the nylon powders are very expensive, and again, those are not eco-friendly. PET is one of the good material which is providing 100% recyclability. So in the image you can see it's a PET material, and the parts created using this filament. The major advantage of PET is it is used in the food industries to create molds for the food processing or containers for the food industry, because those are food safe materials. And another advantage of PET is that it shrinks a little at a higher temperature. So you need to fuse this material at around more 200 to 220 degrees, and during that phase the shrinkage of the material is very little. And again, these are flexible materials. For the wood, the wood dust is combined with a resin based polymer. So on glass fusion temperature, this resin polymerizes and it binds all the wood materials and creates uh, wood based parts. The metals are commonly used metals are copper, brass, aluminum, and some of the alloys, and even carbon fibers are being used as materials, but all those are being used for industrial applications. Now let's understand what are the advantages of 3D printing and what are its limitations. So as I said, in the 3D printing, there is freedom of design. There is no restriction because in the what happens is you are cutting the entire material over the layers and adding the material on those regions, and because of this you can create designs which has internal cavities. You can create materials with any kind of shape. You do not need any specialized tools for that. Whereas in other manufacturing process, you need specialized tools and certain shapes, internal cavities. You cannot create all those things as a single object. Either you split those objects into different parts and then try to connect them, but single part can only be created using 3D printing. Then the time required to set up is very less. Once you have the CAD model, you slice it, you analyze your layers, you analyze the tool path that is being generated over each layers, you analyze the supports required, and that's all. And rest of the time you do not need additional fixtures, you do not need assembly line and all those. So the time for setting up the manufacturing process is very less. It provides a cheap and quick prototyping solutions. So if you have a model of a car, you can create a small prototype of it. So CAD model is already available, you can create a prototype of it quickly, and you can do further testing analysis on that and research work on that. So it helps you quickly and cheaply create the prototypes or samples. I already said that it supports less to zero waste. And the one of the key thing to note here is here the manufacturing skill of the operator is not required. This is mostly oriented over the design and uh, design skills, as well as fine tuning the manufacturing parameters. Uh, Whereas in the conventional, you need the manufacturing skills, like how to what are the steps to be considered for manufacturing. You need to plan the entire manufacturing process. The operator needs to be trained to use different machines. Disadvantage of the 3D printing process is like uh, it is not suitable for very large scale production. So suppose you want to create daily 1,000 pieces, then this particular methods is not suitable because it uh, takes more time. 3D printing takes more time compared to the conventional manufacturing process. And the primary reason for that is this uh, and the entire speed and everything depends upon the design and the material you are being used. Whereas in the mass production, when you are going for mass production, you have proper tools like jigs, fixtures, and even customized cutting tools for that. And because of that, the production can be done at a very high rate. The available of materials for 3D printing is are limited, though over the years the range has increased and lot of material options are available, but still those are limited compared to the material or the objects that you can produce with the conventional manufacturing. uh, then the cost of 3D printed part and the 3D printers increases when you need higher precision and accuracy, because everything is governed by the designs. So with when the precision and accuracy is higher, you need uh, to read those STL files very accurately, then the tool part to be generated very accurately, the tooling or the servo motors that are used to control the material, those needs to be very accurate. So even the controller cost, the tooling cost, everything rises up. And because of this, compared to mass conventional manufacturing, the cost over here keeps on increasing with the accuracy you demand. The another disadvantage or the negative thing that people tend to use 3D printers for is making fake or replicas of an existing object. Uh, and I already mentioned that the mechanical strength of the 3D printed part is comparatively low for compared to the conventional manufacturing processes. So now let's understand what's a typical how is a FDM 3D printer looks like. Okay, so uh, this is a small scale or the hobbyist kind of 3D printer. So most of the parts that I would be showing here are available across all the FDM based 3D printers. So it would have a motherboard uh, where all the firmware for this interpreting the G codes and controlling the tool path is taken care of. There would be a power supply unit. So you have this motherboard, you have power supply unit. Then there is a this black vertical, the horizontal bar, and at the bottom, if you see here, this is the entire frame on which uh, of the 3D printer. So this frame, so most of the time, these frames are made up of aluminum alloys. Uh, then there is this user input unit where you can see like what is being printed, what is the current location of your nozzle, uh, and you control the parameters of the 3D printer from here. Now coming to the basic like the core parts. So this is the uh, y-axis, this is x-axis, and vertical is z-axis. So these are the axes of this particular printer. Uh, Now, along the XY axis, there is a build plate. This build plate is getting heated up uh, to max of like it depends upon different manufacturers and different 3D printers. So this printer build plate is heated up, and that is used for creating adhesion between the first layers and the material, and also keep on adding little bit of heat so that the uniform cooling of the material is happening. So this is a build plate. Then all the tooling path is governed by stepper motor. So here you can see this is a x-axis stepper motor. So there is a belt which is going through in from this frame, x-axis frame, and which controls the movement of this nozzle. So here you see this is a nozzle. These are the cooling fans. There is one cooling fan over here, one cooling fan over here. So what it does is it pulls the air from the outside and blows it over the nozzle. So this keeps a track that the nozzle is never overheated, and this particular fan is used to cool the material which is being printed. Then there is Then there is extruder. So here you see extruder assembly. So here there are gears available, which pulls the material or the material filament and passes through this PTFE tube into the nozzle. So it keeps on pushing this material, and even when the printing is finished, it pulls the material back, so that nozzle is always empty. Okay. So and the another important parts are this screws. So these are bed leveling screws that these are used to level the gap between, or to have a uniform gap between the nozzle and the print bed. So I'll explain like why that gap is important later. So that is one. And here you see these are the limit switches. This is z-axis limit switch. This is x-axis limit switch. This defines what is the home position or 0 0 position along each axis, and there is a limit switch backside or behind this printer. So these are all. And the z-axis movement is governed by a lead screw which is behind this particular frame, and on that on that lead screw, this entire extruder assembly moves up and down. Okay. S- so this is how a 3D printer looks like. So now let's understand the applications of 3D printing. So I have divided the different applications into categories such as research and educational purpose, artistic items, custom parts, functional models, presentations, and mold and patterns. So what does this mean is, like 3D printing is used for research and educational uh, purpose. So when you develop prototypes and all those are mostly for the research work. uh, so you print the part, you do some testing on that part, for aerospace and automotive industry, what they do is they print the part, scaled part, and then do the wind analysis or the CFD analysis on that part, to check like what is the wind flow, and what are the drag, how is the drag happening, what is the direction, what is the pressure that is being built across the different topology of the object. In educational purpose, it is used to demonstrate different internal parts of an object. Instead of purchasing a complete engine of an automobile, what they do is they print a scaled 3D printed model of an actual engine, and they can use for educational purposes. They even for understanding different mechanisms, instead of manufacturing a whole new assembly, they print those assemblies and demonstrate or learn. For artistic applications, it is mostly used by sculptors and artisans, where they create uh, instead of creating statues using marbles, clay, wood, they print those things, so that they print those statues with 3D printers. Even many of the showpieces are getting created, are built using 3D printing. Then jewelry, in jewelry designing also the 3D printing is playing a very important role. And it is getting a lot of response from the jewelry designers, because instead of showing the design or the 2D design of a jewelry, they prefer to 3D print the entire jewelry, show it to the customer. If they like it, they manufacture it with the gold or whatever material they are preferring. Then for the footwears, toys, furnitures, all those are the different applications where 3D printers are being used. Then custom parts. So whenever there are required that you need few customized parts, 3D printer is used for that. So one of the very good domain for that is in the experimentations. So whenever there are experiments done, or for the experimentation, there are custom parts that are created, uh, and those custom parts can be created using 3D printers. Another custom parts application is in the orthopedics and the dentistry domain of medical science. Here, the dental or the uh, artificial teeth. So after you remove your original bone based teeth, you can replace, currently we get it replaced with some ceramic material. The teeth, we make it of ceramic or some metal like gold or neutral material. But now 3D printer is coming into the play where the dentist remove your original teeth, they scan it, and then the using that scan, a 3D printed replica of your original teeth is getting is built, and that is inserted. For orthopedic department, the implants are coming into the picture where customized implants for different patients are being manufactured and operate and the patients are operated with that. Even exoskeletons are being made with 3D printed technology. So these are all the different domains in the medical science area where 3D printing technology is being used. Then for presentations, so in this presentation domain, it is mostly used by architects and civil engineers, where the entire site, they 3D print it, the model, the architectural model, they 3D print it, and they use it as a demonstration purpose of their designs. Then for molds and patterns making, so these molds and patterns are used uh, by artisans and other domains also. Even in the food industry, these molds and patterns are used, so these 3D printed molds are created. So here is an image which shows you what are the different areas of 3D printed parts and how complex objects you can print. So if you see in the vertical, if you see this, these are the complex objects that are the designs which is not possible to build with the traditional manufacturing, but using 3D printed you can create this. Here you can see like how the engine block is 3D printed, and it is used for educational and research purpose to understand how the assembly is going to happen. Even this is used for training employees, the workforce, like how to operate this machine and what is the technology and how, where all parts will go. So this is a good example of that. Then here how the artist used to create the statues or miniatures of the person. So this particular example is using the photogrammetry technology to create the CAD model and then 3D printing it to build this particular statue. These are some wall units that are manufactured using 3D printing. Then this is another example of like learning the mechanisms. So this is a radial engine. So that is a 3D print. So entire assembly is 3D printed, and it shows like how it's working and what is the mechanism of it. Then here you see the exoskeleton. So for individual human being, uh, based on their palm size and all, you can create such parts, and they help in their recovering, either if they have certain disabilities or uh, then this kind of 3D printed exoskeletons helps in recovering those disabilities. This bottom picture, if you see, it shows you uh, that this is a 3D printer head assembly, that print head assembly that I had showed you previously. But instead of using that stock assembly. This is a 3D printed or custom assembly where stock was supporting only two single fan for the printed filament or to cool down the printed filament. But here the hobbyist wanted to use a two fan for his application, and for that he has created a custom part for his 3D printer. So now there are two fans, and he has created he has provided uh, the assembling the extruder assembly directly on the nozzle or the print head instead of the stock method. So this is how the 3D printing is being used for creating custom parts or for your specific applications. Now let's understand what are the different challenges. So these are the challenges which whenever user is using 3D printing will come across as a day-to-day activity. So from those day-to-day activities, I have identified some of the most frequently having problems with the 3D printing. I've been using this 3D printer for past couple of years, and because of that, I've these are my experiences that I'm sharing with you all. So one of the most common problem is that the printing of the first layer, the layers does not stick with the bed properly, and because of this the entire print fails. So what is the common or the troubleshooting that you can do is, if the temperature for the filament is not proper or the temperature of the bed is not proper, this kind of issues occur. uh, and so what is the challenge over here to solve this problem is, uh, like if you have material with a very high temperature, it or the bed with a higher temperature, it will add additional thermal loads, and thus it would be imposing residual stresses on the 3D printed part. So the 3D printed part would have thermal loads on it. But if you cool the material very quickly, or if the temperature is kept low, the problem or the bed temperature is low, the adhesion would be a problem, and there would be a problem the material will start wrapping up. If the bed temperature is very high, then the material from the first few layers would start shrinking up, and these are the challenges, and you need to fine tune all these things based on the material that you are using, based on the design that you have, and with the specification of your 3D printer. Another problem with the bad adhesion is with the bad adhesion, another solution that you can try is use the magic glue. So there is a specialized glue that it comes, uh, which you can stick it on the bed, and then you start the printing. So what happens is this glue expands, and uh, like it sticks, whenever the printing starts for the for the first layer, it's uh, builds a lot of adhesive force between, or it sticks the material with the build plate. And because of that, because the first layer is stick properly, the rest of the layers get printed properly. The problem using the magic glue is, it is not the normal glue that we use it in the office. These are the specialized glues, because the office glues that we use, sometimes the materials are not compatible with them. So they build a specialized glue for this 3D printing purpose. Another issue with using glue is it absorbs moisture, and because of the moisture, the temperature of the filaments are comparatively higher, like around 200 to 10. And because of that, it damages the material properties of the filament, and the curing doesn't happen, or the water gets trapped inside the material, so your mechanical properties deteriorate for the print part. And another and the most manual issues that happen with the glue is, if the glue is not stick uniformly, it damages, it creates bumps, or there is unevenness in the first layer. So after printing, you see there is unevenness in the objects, so you need to apply this glue in a uniform manner, and then you need to do a bed leveling again after the application of the glue. Another problem that is faced is in the surface, like the surface finish. So here in the image you can see that you can see the layers. So this is how the printing has happened in this direction, and layer by layer the material is getting added. So for certain applications, like in an artistic or some other application, this is not visually appealing, and because of that, your printed objects might not look good. uh, so the only solution, like this is how the 3D printing, so whatever method you use, SLA, FDM or SLS, in all these methods this is going to be a common problem. And for that, the only solution is you create a little bit of oversized object and do a sanding of it. So you take some sandpaper, rub those sandpaper, and remove the material so that it appeals uniform, and a smooth finish is obtained. The problem with the sanding is, it is a very tedious job. It takes lot of time. When you are using plastics and other, it takes lot of time. uh, then while sending, the temperature again rises, which again damages the mechanical properties, and it might distort the current shape. Another problem is, like, due to sanding, and if you are doing a manual sanding, the dimensional inaccuracy is achieved. So if you are having if you have lot of if you are using printing this particular for some uh, mechanism, or you are designing some mechanism for that, this part is created, then tolerances and all those gets changed, and it creates uneven surfaces and dimensional inaccuracy. So another solution is you decrease the layer thickness, and because of that, the layers would be very close, and lot of this surface roughness is removed with that. Now, the third way to improve the surface finish is using acetone smoothing method. This method is only applicable for ABS material. So in the image, you see how the owl was printed layer by layer, and then using acetone smoothing, it got smooth and it had a glossy finish. So this kind of objects appeal for certain applications. The challenge using acetone smoothing is that there is no user control on how this acetone vapors would remove material from different areas of your printed part. And if the part is overexposed to this acetone vapors, then your printed part would deteriorate. The advantage of using acetone smoothing method is, acetone vapors tries to melt down the outer surface of the object, and because of this, all the layers uh, stick together very properly. So the acetone smoothened 3D printed part are having higher mechanical strength compared to the normal or untreated 3D printed part. Now for the bed leveling. So there are a lot of issues which are related to bed leveling. So in the top image, if you see, because of uneven bed leveling, the layers are not the first layer is not printed properly. So here you can see that lot of scratching is happening, then there is scratching is reduced, and then there are cracks getting developed. So this is due to poor bed leveling. So across the bed, the gap between the nozzle and the print bed should be always uniform. Now, uh, the another issue with the bed, this gap. So how you should define what is the good gap between the print bed and the nozzle. So if you see this bottom image, you see that as the gap increases, the print quality is getting deteriorated. And that is because the material, the filament that is coming is not able to stick properly on the previous layer. And because of this, this deterioration happens. But another thing is, if you go too close to the material, there may be scratching issues. Uh, and there might be scratching issues, there may be, because nozzle is a very heated, so those the nozzle, the thermal load would be acting upon, so a concentrated thermal load would be acting during the printing, and because of this, uh, transition of this like transition from the glass temperature to glass fusion temperature to the normal room temperature, those cycles are getting disturbed. So for for your design, you need to identify what is the best gap, and whenever you are printing, you need to check the uh, gap between nozzle and print bed frequently, and always, like, a thumb rule should be like, before printing you should always check the leveling. Now the fan speed. So this fan speed is actually for providing the cooling mechanism for the no for the printed area. So here in the image I'll show you. uh, okay, so here in the image, if you see, this is the printing zone. In the printing zone, if you provide air over here, it starts cooling immediately. So these are the different um, areas, like how this printing is getting affected. So when you don't have any cooling, or the fan is not blowing any air, the cooling takes a lot of time. So the advantage of this particular method is, like, because the previous layer has not cooled down completely and it's still in partial glass transition state, the newly printed layer sticks very perfectly, or the bonding is very high, and because of this the mechanical strength is increased. But the issue with uh, not providing cooling is when you have overhangs, cantilever portions where the support is very minimal, because the cooling is not happening, it starts distortion. So here you can see that when the cooling was not there, all these portions, those became the weak zones, and it started distorting. So all these portions started distorting, if you see. Whereas when you started providing some cooling, uh, the overall object that got built has improved, the build quality has improved. So and this is a trade-off between how cooling, do you want to provide cooling or you don't want to provide cooling, and all this trade-off needs to be taken based on the design and material you are using. So for every design, this particular parameter keeps on changing. Now another common issue is with the stringing on oozing. So here you can see in the image that this filament very very thin, like they are thinner than the hairs of human. So these filaments are getting, or they are sticking to your uh, print printed objects, and this is happening when the nozzle is moving from printed zone to non-printed zone, or some newly or a different print zone. So here you are building here you are printing pillars, and between that there is no printing to be done. So what it does is, when it is moving from this location to this location, this nozzle is pushing, or it is oozing some of the material. And this is happening, the primary reason for this is the temperature of the nozzle is very high, and because of this the material inside the nozzle has gone into more of molten state, and because of this it is coming out properly. Second issue is like after printing, when it is moving, the material should be retracted from the nozzle, so nozzle should get empty, but that is not happening. And to correct this particular kind of build failures, what you need to do is you need to correct, or you need to check the retraction distance that is to be done, and you need to reduce the the printing temperature or the nozzle temperature. Also, this can happen when you have very high speeds. The retraction speed is not matching with the print speeds, and because of this material is not getting retracted from the nozzle. So again, you can also check and lower the printing speed, and this will help you to solve this particular problem. So here you need, these are all the trade-offs that you need to do, and this would come, like you will be able to come understand and solve these things with the experience and the materials you are using, and when you get more familiar with the 3D printer that you are using. So as I said, either you reduce the temperature, increase the fan speed. So when you are increasing the fan speed, the cooling has happened, and it will break all this particular stringate or the wires that are coming from the nozzle, and then this will prevent this kind of build failures. Now, nozzle is getting clogged. This is one of the most common problems with the 3D printing thing, and especially with the FDM, that after certain layers the printing is complete, the nozzle gets clogged, and because of that filament is not coming, and then you lose the printing, or the object, the printing job fails. So the primary reasons for that is nozzle is the nozzle is very close to the bed, and because of that uh, the filament that should come out is not coming out properly, and it is getting like it is building a pressure on the nozzle uh, for not coming out properly, and because of this it starts sticking to the inner walls of the nozzle. So the nozzle has a very small diameter, like zero point 0.4 to zero point 0.1 mm, and even like for higher accuracy it grows below those, the opening of that nozzle. So for that small opening, if you don't provide a proper gap, the filament doesn't come out properly, and because of that, after some certain amount of printing done, the amount of material that got deposited inside the nozzle increases, and it stops extracting the filament further. Then the nozzle temperature is very low, that is also another reason. And what it does is the material is not at the proper glass transition temperature, and because of this the material is uh, at a at a lower zone of this class transition. So it has not completely become in the fused state, and it is not able to smoothly come out of the nozzle. So either you increase the nozzle temperature and check your printing. Then another reason is that because of that oozing issue that we discussed previously, because of that the nozzle is oozing a lot of filaments, and after your printing has done, you are not able you have not retracted the filament completely, and because of this the mold the fused state of the nozzle deposits inside the nozzle, and it solidifies, and then prevents nozzle to work properly, or the material doesn't come out. And another issue is like the filament got damaged. So whenever filament is getting pulled, those are getting pulled through the extruder gears, and because of high printing speeds, this extruder gears put impressions on this filament and change the diameter of this filament, and because of this the filament is getting damaged, and this damaged filament is getting deposited in inside the nozzle, and that causes the blocking of the filament. So now I'll walk you through a demo. So I'll walk you through a demo where I'll be showing you the entire workflow from designing to the printing. So in this particular example, what I am showing you is uh, like from a non how artisans use 3D printers to create certain objects. So this is like how you are creating an ink stamps using 3D printing. So using this vector software, that is Adobe Illustrator or Inkscape, you are building the design, and this design we are importing inside the CAD software, the engineering CAD software, to create the 3D model. So now your 3D printed model is ready. So for printing this, as I said earlier, we need to export it in a neutral format. So we are exporting it as a in an STL format. So Cura is one of the slicer that we can use. So it's a free slicer provided by Ultimaker. So Ultimaker is also a manufacturer of 3D printer. And then the STL, when you import it, it's a tessellated object, and then you start like defining the different parameters for 3D printing, like what is the infill density, what is the infill pattern you want, then what is the print speed, what is the temperature of the nozzle, what is the filament size, what is the nozzle size. So I'm using different filaments you export after. So if you see here, so now what I have done is I have generated the tool path, and when I preview, I see what is the tool path, and across layer how the nozzle would be moving. And then I use this tool path that is generated, I use it, I feed it inside the printer, and I start printing. So this is the lead screw that I was talking about. Here is the nozzle. So for this print job, the nozzle temperature is 210, and the print bed temperature is 50 degrees. And here you see how the printing is happening layer by layer. Yep. So now we are open for any questions that anyone has.
Okay, thank you, Ronak, for the informative and the interactive webinar. Now we will go with the question answer session. So I will just read out the question, then we can discuss
Mhm.
how 3D pen is different from 3D printer on functional basis.
So 3D pens are nothing but FDM based printers, but instead of using stepper motors and controlling the movement of the nozzle, here also nozzle is deployed, but instead of that, you are using the hand as controlling the movement of the path, and you are doing the printing. So those 3D pens are used only for the artistic purposes or some very like for hobbies purpose, but it is not accepted in the industry or not used by the industry.
Okay. Next question. Mm, we manufacture hollow as well as spherical part in 3D printing machine.
Yes, we can do. We can print spherical parts. We can print hollow parts. Anything. So as I showed you, we need to do proper slicing. If overhangs are provided, then we need to provide proper support so that during the printing there is no distortion in the shape. And once the printing is done, you remove all those supports.
Okay. How 3D printing is useful in construction industry?
So I'll give you a real case
Ronak,
scenario. Uh,
Ronak,
yes.
your voice is lagging. Break type आवाज.
Hello. Is it audible properly now?
No, your voice is audible, but
Hmm?
there is some lagging in your voice. Break type break.
Oh, maybe some internet issue intermittently.
हाँ, do one thing, just switch off your video. Video switch off कर
Okay.
दो.
Okay. So,
हाँ,
for the construction industry, let me give you a practical example. So that in Europe, the SAW system has in their Velizy head office, they have printed igloo, a real igloo for a human being in their campus using 3D printed technology. So instead of using plastics and all, they have used robotic arms to do the printing, and instead of using plastics, they are using cements with the fused concrete inside it to create the entire igloo. So that is an example. Now even in certain European countries, the entire house walls are getting created using 3D printing technology.
okay. What is the scope of 3D printing in construction industry? What material and method is used? Does it have a strength enough to sustain as conventional construction methods?
Yeah, that I have already.
Hello. Wait for a while. Hello.
Yeah.
Ronak.
Hello. Sorry, it got disconnected. Some
Okay,
net.
fine.
Okay. So as I was saying, for the construction industry, the same materials are being used as for 3D printing, like concrete with sand and other aggregate mixtures, and the buildings or the constructions is being done. So this is all happening for improving the accuracy, creating certain innovative designs in the construction industries also. So this is very innovative technology that is being adopted in the construction domains also.
Okay. Which software are used in industry for slicing of STL file? Please enlist a few of them.
So these softwares are actually provided by the, different 3D printers that you purchase. So based on the different 3D printers, they provide their own softwares for doing the slicing work. And this is because once the slicing is done, the tool path needs to be generated, and this tool path are sometimes specific to the machines that you use.
3D printing is how to help in mechanical engineering.
So
Please
I
say
have
about please say about the accuracy of 3D printer.
Yeah, so I have said like I gave you the examples. These 3D printers are being used for the actual industrial application. So in the aeronautical domains, many brackets. Even if you see for the aeroplanes, the chassis for the uh, landing assembly, those are now started getting created using 3D printing technology. Not only this, the entire car in the initially in the first slide only I had told you about this, that the entire car body was 3D printed using carbon fiber material, and which is now commercially available. So these are all the industrial applications where the 3D printing is being used in the mechanical engineering domain. The accuracy is different for different printers. So recently, like I had checked with my friend who is working in Mercedes, Singapore. So he said that the 3D printer that they are using, they have a accuracy of in terms of nanometers. So that is a very high accurate 3D printers which is capable of printing alloys. So not only like carbon fibers or plastics, but industrial 3D printers are available which are printing metallic alloys. For the hobbyist and all those, the printing accuracy is less because their industrial application is not that much.
Okay. Which method is more efficient if I want to 3D print size accuracy 0.5 mm with tough material in nature?
So I had already told you, like everything depends upon the design, the application you want. So tough material means if you want to go for metal printing, you select metallic material. So either you can go for fused deposition, or you can go for like stereolithography or SLA is not supporting the metallic printing, whereas other two like FDM and SLS both are supporting metallic printing. So you can print metallic objects using 3D printing. And
Okay.
for the size accuracy, everything depends upon the 3D printer that you are using. So the basic models that are available for the 3D printer, those start with 1 to 0.5 or to certain extents of zero point 0.2 or zero point 0.3 of accuracy.
Okay. This 3D printer is universal with all type of material or vary with the quality of the material.
No, the printing quality varies with the material. So there are tons of materials available, and as I said, like different materials react with different environment, and it depends upon how you're designed. So for certain designs, you cannot use certain material. Like if you are using a flexible material for a design where it has lot of overhangs and all, so those printing would fail. So you need to identify for which design which all materials are suitable, and then you should select the printing material. And
Okay.
printing quality definitely depends upon the print material. So for SLS, the powder quality, like the powder size, that controls the printing quality. For FDM, the printing quality is defined by the size of the diameter of the filament that you are using. Even if the filament absorbs the moisture, it deteriorates the printing quality.
Okay. Which reason we use the raw material in powder form?
I Which reason or which material do we use? I think there is some issue. So
Which?
powder material is used
Mhm.
because we need to fuse. If you have a block of material, you cannot fuse that thing and create a solid part. So there are small powder in a so this powder is nothing but a small tiny spherical parts, and when you apply temperature, those fuse and create a single object. And this is how the fuse deposition this is how this laser sintering works.
Okay. Which type of defects we show in 3D printer parts?
So I showed you like what are the different defects that are coming. So if your filament, if you are using FDM method, and the filament has moisture, then it would have cavities inside between the layers. Then there would be like clots happening on the outer surface, and that is because the nozzle is oozing. Even like stringing, I had showed you the example. So stringing, that is also defects in the 3D printed part. Then delamination is happening because the layers are not sticking properly. So the fusion between the two layers, previous layer and current printing layer, is not proper, and that is causing delamination. So these are all different defects in the 3D printing.
Okay. What what about the minimum and maximum limit of size of printed material?
So again, that is printer specific. So as I said, like hobbyist would start from a built volume of 100 by 100 by 100 volume, to the industrial application where they are printing the entire car, or they are building the entire house using 3D printing technology. So size depends upon the printer, your applications.
Okay. Are the shape CAD models always converted in small triangular shapes only during processing? Why not any other shape? Any specific reason?
So
Continuation with this, is there any method to overcome the strength issue in z-axis or to increase overall strength of 3D printing parts?
okay, so to explain this thing, it is a this particular question is more related to the CAD modeling and the geometry part of the CAD domain.
Hmm.
So what is happening is what every software is using a different geometry kernel within it, and this kernel represents the all the shapes that you are used for your CAD model in some or the other uh, computer objects or the programming objects, and these objects represents are used to store the entire CAD model data. So in the visual or on the screen, you would be seeing that you are storing it as a uh, you are seeing the spheres or you are seeing some curves, but actually internally it is stored as objects, serialized objects of based on the kernel that the software is using. Now this data structure is not open, and these are the trademarks or different softwares, and every software provides licensing for this. So whenever you are purchasing a software, you are purchasing the license for using those kernels. Now those kernels cannot be read, or the serialized objects of those kernels cannot be read by another software. So the CAD community came up with some neutral format where they say you export this geometry in form of triangular or tessellated objects. So triangles are selected because that will help you to build more accurate models. If you have a spherical objects, then representing square surfaces or the curves is very difficult. Whereas with the triangular faces, you can represent those things very clearly. So that is a common format or the common approach that have been adopted by the CAD industry, and all the CAD softwares support those things. So that
Okay.
is why we convert everything, because at the end we need to import that model in the slicer, so that would be using a different geometry kernel inside it, and so the transition of the design from one tool to another tool is maintained.
Okay. Does this printer is used in electrical engineering?
Yes, this 3D printing is also used in electrical engineering for printing PCBs. So earlier the PCBs were printed using chemical processes. Now the PCBs are also printed using 3D printed technologies.
Okay. So I hope all the questions are covered by our today's speaker, that is Ronak Shah. Now, if anybody want to ask directly to the speaker, they can unmute yourself and ask your query or any doubt to Ronak. So he will definitely solve your query and share his thoughts regarding the questions which is asked by you. And if no questions, then we can conclude our today's webinar. So before concluding the webinar, I would like to call one or two participants for the feedback. So if anybody is interested to give the feedback, please unmute yourself and say a few words regarding today's webinar. Any participant or student, faculty, or anyone from the industry who would like to share anything regarding today's webinar, most welcome. Okay, now I will call the names. Avi Gandhi, if you are here, then kindly share your feedback regarding today's webinar.
Yes, sir, I am present. The webinar session was very informative and in detail. I have never seen such in detail explanation with practical approach also. And even Q&A sessions were not like one-liners; they were completely in detail. So I enjoyed attending it, and I gained a lot of information from it, not only theoretical but practical approach also. Looking forward for more such webinars. Thank you.
Thank you, Avi, for the kind words regarding today's webinar. Any other students or faculty member? I have shared the feedback and certificate link in the chat box. All the participants, please go through the link and submit your feedback. And please write your email address, correct email address, so that you will get your certificate in instant automatic. But if you write the email address wrongly in the Google form, then it will not reach to you through email address. And once again, all the participants, we have the series of webinar means from 13 to 16. The link I will share with you daily in the evening. So tomorrow also we will have the session of cyber security. The speaker, Professor Deepak Upadhyay from GTU, he is the assistant professor. So we will again meet tomorrow for the another emerging area in engineering and technology, that is on cyber security. So once again, on behalf of all the participants, SSIP DIC Cell, I would like to thank our today's speaker Ronak for delivering such a wonderful and interactive session with, as Avi said, that with practical approach. So I hope student will get maximum advantage out of it, and they will also learn something out of it. So once again, thank you all the participants. Also, we will meet tomorrow for the next webinar. Thank you so much.
Yeah, thank you guys.
So now I'm ending this session.